This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Fairyland of Science by Arabella Buckley. Read and recorded by Patricia Oakley. Preface. The 10 lectures of which this volume is composed were delivered last spring in St. John's Wood to a large audience of children and their friends, and at their conclusion I was asked by many of those present to publish them for a child's reading book. At first I hesitated, feeling that written words can never produce the same effect as viva voce delivery. But the majority of my juvenile hearers were evidently so deeply interested that I am encouraged to think that the present work may be a source of pleasure to a wider circle of young people, and at the same time awaken in them a love of nature and of the study of science. The lectures have been entirely rewritten from the short notes used when they were delivered. With the exception of the first of the series, none of them have any pretensions to originality, their object being merely to explain well-known natural facts in simple and pleasant language. Throughout the whole book I have availed myself freely of the leading popular works on science, but have found it impossible to give special references, as nearly all the matter I have dealt with has long been the common property of scientific teachers. Lecture 1. How to enter it, how to use it, and how to enjoy it. I have promised to introduce you today to the Fairyland of Science. A somewhat bold promise, seeing that most of you probably look upon science as a bundle of dry facts, while Fairyland is all that is beautiful and full of poetry and imagination. But I thoroughly believe myself, and hope to prove to you, that science is full of beautiful pictures, of real poetry, and of wonder-working fairies, and what is more, I promise you they shall be true fairies, whom you will love just as much when you are old and gray-headed as when you are young, for you will be able to call them up whenever you wander by land or by sea, through meadow or through wood, through water or through air, and though they themselves will always remain invisible, yet you will see their wonderful poet at work everywhere around you. Let us first see for a moment what kind of tales science has to tell, and how far they are equal to the old fairy tales we all know so well. Who does not remember the tale of the Sleepy Beauty in the wood, and how under the spell of the angry fairy the maiden pricked herself with the spindle and slept 100 years? How the horses in the stall, the dogs in the courtyard, the doves on the roof, the cook who was boxing the scullery boy's ears in the kitchen, and the king and queen with all their couriers in the hall remained spellbound, while a thick hedge grew up all around the castle, and all within was still as death. But when the 100 years had passed, the valiant prince came. The thorny hedge opened before him, bearing beautiful flowers, and he, entering the castle, reached the room where the princess lay, and with one sweet kiss raised her and all around her to life again. Can science bring any tale to match this? Tell me, is there anything in this world more busy and active than water, as it rushes along in the swift brook, or dashes over the stones, or spouts up in the fountain, or trickles down from the roof, or shakes itself into ripples on the surface of the pond as the wind blows over it? But have you never seen this water spellbound and motionless? Look out of the window some cold, frosty morning in winter at the little brook which yesterday was flowing gently past the house, and see how still it lies, with the stones over which it was dashing now held tightly in its icy grasp. Notice the wind ripples on the pond. They have become fixed and motionless. Look up at the roof of the house. There, instead of living doves merely charmed to sleep, we have running water caught in the very act of falling and turned into transparent icicles, decorating the eaves with a beautiful crystal fringe. On every tree and bush you will catch the water drops napping in the form of tiny crystals, while the fountain looks like a tree of glass with long, down-hanging pointed leaves. Even the damp of your own breath lies rigid and still on the window pane, frozen into delicate patterns like fern leaves of ice. All this water was yesterday flowing busily, or falling drop by drop, or floating invisibly in the air. Now it is all caught and spellbound. By whom? By the enchantments of the frost giant, who holds it fast in his grip and will not let go. But wait a while, the deliverer is coming. In a few weeks or days, or it may be in a few hours, the brave sun will shine down. The dull gray, leaden sky will melt before him, and the hedge gave way before the prince in the fairy tale, and when the sunbeam gently kisses the frozen water, it will be set free. Then the brook will flow rippling on again. The frost drops will be shaken down from the trees. The icicles fall from the roof. The moisture trickle down the window pane, and in the bright, warm sunshine all will be alive again. Is not this a fairy tale of nature? And such as these it is which science tells. Again, who has not heard of Catskin, who came out of a hollow tree, bringing a walnut containing 3 beautiful dresses, the first glowing as the sun, the second pale and beautiful as the moon, the third spangled like the starlit sky, and each so fine and delicate that all 3 could be packed in a nut? But science can tell of shells so tiny that a whole group of them will lie on the point of a pin, and many thousands be packed into a walnut shell, and each one of these tiny structures is not the mere dress, but the home of a living animal. It is a tiny, tiny shell palace, made of the most delicate lacework, each pattern being more beautiful than the last. And what is more, the minute creature that lives in it has built it out of the foam of the sea, though he himself is nothing more than a drop of jelly. Lastly, anyone who has read The Wonderful Travelers must recollect the man whose sight was so keen that he could hit the eye of a fly sitting on a tree 2 miles away. But tell me, can you see gas before it is lighted, even when it is coming out of the gas jet close to your eyes? Yet, if you learn to use that wonderful instrument, the spectroscope, it will enable you to tell one kind of gas from another, even when they are both 91 millions of miles away on the face of the sun. Nay, more, it will read for you the nature of the different gases in the far distant stars, billions of miles away, and actually tell you whether you could find there any of the same metals which we have on the earth. We might find hundreds of such fairy tales in the domain of science, but these 3 will serve as examples, and we must pass on to make the acquaintance of the science fairies themselves, see if they are as real as our old friends. Tell me, why do you love Fairyland? What is its charm? Is it not that things happen so suddenly, so mysteriously, and without man having anything to do with it? In Fairyland, flowers blow, houses spring up like Aladdin's palace in a single night, and people are carried hundreds of miles in an instant by the touch of a fairy wand. And then this land is not some distant country to which we can never hope to travel. It is here in the midst of us, only our eyes must be opened, or we cannot see it. Ariel and Puck did not live in some unknown region. On the contrary, Ariel's song is, "Where the bee sucks, there suck I, in a cowslip's bell I lie. There I couch when owls do cry, on the bat's back I do fly, after summer merrily." The peasant falls asleep some evening in a wood, and his eyes are opened by a fairy wand, so that he sees the little goblins and imps dancing round him on the green sward, sitting on the mushrooms, or in the heads of the flowers, drinking out of acorn cups, fighting with blades of grass, and riding on grasshoppers. So, too, the gallant knight, riding to save some poor oppressed maiden, dashes across the foaming torrent, and just in the middle, as he is being swept away, his eyes are opened, and he sees fairy water nymphs soothing his terrified horse and guiding him gently to the opposite shore. They are close at hand, these sprites, to the simple peasant or the gallant knight, or to anyone who has the gift of the fairies and can see them. But the man who scoffs at them, and does not believe in them or care for them, he never sees them. Only now and then they play him an ugly trick, leading him into some treacherous bog, and leaving him to get out as he may. Now, exactly all this which is true of the fairies of our childhood is true too of the fairies of science. There are forces around us and among us, which I shall ask you to allow me to call fairies, and these are 10,000 times more wonderful, more magical, and more beautiful in their work than those of the old fairy tales. They too are invisible, and many people live and die without ever seeing them or caring to see them. These people go about with their eyes shut, either because they will not open them, or because no one has taught them how to see. They fret and worry over their own little work and their own petty troubles, and do not know how to rest and refresh themselves by letting the fairies open their eyes and show them the calm, sweet pictures of nature. They are like Peter Bell, of whom Wordsworth wrote, "A primrose by a river's brim, a yellow primrose was to him, and it was nothing more." But we will not be like these. We will open our eyes and ask, what are these forces or fairies, and how can we see them? Just go out into the country and sit down quietly and watch nature at work. Listen to the wind as it blows. Look at the clouds rolling overhead and waves rippling on the pond at your feet. Hearken to the brook as it flows by. Watch the flower buds opening one by one, and then ask yourself how all this is done. Go out in the evening and see the dew gather drop by drop upon the grass, or trace that delicate hoarfrost crystals which bespangle every blade on a winter's morning. Look at the vivid flashes of lightning in a storm, and listen to the pealing thunder, and then tell me, by what machinery is all this wonderful work done? Man does none of it. Neither could he stop it if he were to try. For it is all the work of those invisible forces, or fairies, whose acquaintance I wish you to make. Day and night, summer and winter, storm or calm, these fairies are at work, and we may hear them and know them, and make friends of them if we will. There is only one gift we must have before we can learn to know them. We must have imagination. I do not mean mere fancy, which creates unreal images and impossible monsters, but imagination, the power of making pictures or images in our mind of that which is, though it is invisible to us. Most children have this glorious gift, and love to picture to themselves all that is told them, and to hear the same tale over and over again till they see every bit of it as if it were real. This is why they are sure to love science if its tales are told them aright, and I, for one, hope the day may never come when we may lose that childish clearness of vision which enables us to see through the temporal things which are seen, to realize those eternal truths which are unseen. If you have this gift of imagination, come with me, and in these lectures we will look for the invisible fairies of nature. Watch a shower of rain. Where do the drops come from, and why are they round, or rather slightly oval? In our fourth lecture, we shall see that the little particles of water of which the raindrops are made were held apart and invisible in the air by heat, one of those most wonderful of our forces, or fairies, till the cold wind passed by and chilled the air. Then, when there was no longer so much heat, another invisible force, cohesion, which is always ready and waiting, seized on the tiny particles at once and locked them together in a drop, the closest form in which they could lie. Then, as the drops became larger and larger, they fell into the grasp of another invisible force, gravitation, which dragged them down to the earth, drop by drop, till they made a shower of rain. Pause for a moment and think. You have surely heard of gravitation, by which the sun holds the earth and the planets and keeps them moving round him in a regular order. Well, it is this same gravitation which is at work also whenever a shower of rain falls to the earth. Who can say that he is not a great invisible giant, always silently and invisibly toiling in great things and small whenever we wake or sleep? Now the shower is over, the sun comes out, and the ground is soon as dry as though no rain had fallen. Tell me, what has become of the raindrops? Part, no doubt, have sunk into the ground, and as for the rest, why, you will say the sun has dried them up. Yes, but how? The sun is more than 91 millions of miles away. How has he touched the raindrops? Have you ever heard that invisible waves are traveling every second over the space between the sun and us? We shall see in the next lecture how these waves are the sun's messengers to the earth, and how they tear asunder the raindrops on the ground, scattering them in tiny particles too small for us to see, and bearing them away to the clouds. Here are more invisible fairies working every moment around you, and you cannot even look out of the window without seeing the work they are doing. If, however, the day is cold and frosty, the water does not fall in a shower of rain. It comes down in the shape of noiseless snow. Go out after such a snow shower, on a calm day, and look at some of the flakes which have fallen. You will see, if you choose, good specimens. that they are not mere masses of frozen water, but that each one is a beautiful six-pointed crystal star. How have these crystals been built up? What power has been at work arranging their delicate forms? In the fourth lecture, we shall see that up in the clouds another of our invisible fairies, which, for want of a better name, we call the force of crystallization, has caught hold of the tiny particles of water before cohesion had made them into round drops, and there silently but rapidly has molded them into those delicate crystal stars we know as snowflakes. And now, suppose that this snow shower has fallen early in February. Turn aside for a moment from examining the flakes, and clear the newly fallen snow from off the flower bed on the lawn. What is this little green tip peeping up out of the ground under the snowy covering? It is a young snowdrop plant. Can you tell me why it grows? Where it finds its food? What makes it spread out its leaves and add to its stalk day by day? What fairies are at work here? First, there is the hidden fairy Life, and of her even our wisest men know but little. But they know something of her way of working, and in Lecture 7 we shall learn how the invisible fairy Sunbeams have been busy here also, how last year's snowdrop plant caught them and stored them up in its bulb, and how now in the spring, as soon as warmth and moisture creep down into the earth, these little imprisoned sun waves begin to be active, stirring up the matter in the bulb and making it swell and burst upwards, till it sends out a little shoot through the surface of the soil. Then the sun waves above ground take up the work and form green granules in the tiny leaves, helping them take food out of the air, while the little rootlets below are drinking water out of the ground. The invisible Life and invisible Sunbeams are busy here, setting actively to work another fairy, the force of chemical attraction, and so the little snowdrop plant grows and blossoms without any help from you or me. One picture more, and then I hope you will believe in my fairies. From the cold garden you run into the house and find the fire laid indeed in the grate, but the wood dead and the coals black, waiting to be lighted. You strike a match, and soon there is a blazing fire. Where does the heat come from? Why do the coals burn and give out a glowing light? Have you not read of gnomes buried deep down in the earth, in mines, and held fast there till some fairy wand has released them and allowed them to come to earth again? Well, thousands and millions of years ago, those coals were plants, and like the snowdrop in the garden of today, they caught the sunbeams and worked them into their leaves. Then the plants died and were buried deep in the earth, and the sunbeams with them. And like the gnomes, they lay imprisoned till the coals were dug out by the miners and brought to your grate. And just now you yourself took hold of the fairy wand which was to release them. You struck a match, and its atoms, clashing with atoms of oxygen in the air, set the invisible fairies' heat and chemical attraction to work, and they were soon busy within the wood and the coals, causing their atoms too to clash, and the sunbeams, so long imprisoned, leaped into flame. Then you spread out your hands and cried, "Oh, how nice and warm!" and little thought that you were warming yourselves with the sunbeams of ages and ages ago. This is no fancy tale. It is literally true, as we shall see in Lecture 8, that the warmth of a coal fire could not exist if the plants of long ago had not used the sunbeams to make their leaves holding them ready to give up their warmth again whenever those crushed leaves are consumed. Now do you believe in and care for my fairyland? Can you see in your imagination fairy cohesion ever ready to lock atoms together when they draw very near to each other? Or fairy gravitation dragging raindrops down to the earth? Or the fairy of crystallization building up the snowflakes in the clouds? Can you picture tiny sun waves of light and heat traveling from the sun to the earth? Do you care to know how another strange fairy, electricity, flings the lightning across the sky and causes the rumbling thunder? Would you like to learn how the sun makes pictures of the world on which he shines, so that we can carry about with us photographs or sun pictures of all the beautiful scenery of the earth? Have you any curiosity about chemical action, which works such wonders in air and land and sea? If you have any wish to know and make friends of these invisible forces, the next question is, how are you to enter the fairyland of science? There is but one way. Like the knight or peasant in the fairy tales, you must open your eyes. There is no lack of objects. Everything around you will tell some history if touched with the fairy wand of imagination. I have often thought, when seeing some sickly child drawn along the street, lying on its back while the other children romp and play, how much happiness might be given to sick children at home or in hospitals, if only they were told the stories which lie hidden in the things around them. They need not even move from their beds, for sunbeams can fall on them there, and in a sunbeam there are stories enough to occupy a month. The fire in the grate, the lamp by the bedside, the water in the tumbler, the fly on the ceiling above, the flower in the vase on the table. Anything, everything has its history and can reveal to us nature's invisible fairies. Only you must wish to see them. If you go through the world looking upon everything only as so much to eat, to drink, and to use, you will never see the fairies of science. But if you ask yourself why things happen, and how the great God above us has made and governs this world of ours, if you listen to the wind and care to learn why it blows, if you ask the little flower why it opens in the sunshine and closes in the storm, and if, when you find questions you cannot answer, you will take the trouble to hunt out in books or make experiments to solve your own questions, then you will learn to know and love those fairies. Mind, I do not advise you to be constantly asking questions of other people, for often a question quickly answered is quickly forgotten. But a difficulty really hunted down is a triumph forever. For example, if you ask why the rain dries up from the ground, most likely you will be answered that the sun dries it, and you will rest satisfied with the sound of the words. But if you hold a wet handkerchief before the fire and see the damp rising out of it, then you have some real idea how moisture may be drawn up by the heat from the earth. A little foreign niece of mine, only 4 years old, who could scarcely speak English plainly, was standing one morning near the bedroom window, and she noticed the damp trickling down the window pane. "Auntie," she said, "what for it rain inside?" It was quite useless to explain to her in words how our breath had condensed into drops of water upon the cold glass. But I wiped the pane clear and breathed on it several times. When new drops were formed, I said, Sissy and Auntie have done like this all night in the room." She nodded her little head and amused herself for a long time, breathing on the window pane and watching the tiny drops. And about a month later, when we were traveling back to Italy, I saw her following the drops on the carriage window with her little finger and heard her say quietly to herself, "Sissy and Auntie made you." Had not even this little child some real picture in her mind of invisible water coming from her mouth and making drops upon the window pane? Then again, you must learn something of the language of science. If you travel in a country with no knowledge of its language, you can learn very little about it. And in the same way, if you are to go to books to find answers to your questions, you must know something of the language they speak. You need not learn hard scientific names, for the best books have the fewest of these. But you must really understand what is meant by ordinary words. For example, how few people can really explain the difference between a solid, such as the wood of the table, a liquid as water, and a gas, such as I can let off from this gas jet by turning up the tap. And yet any child can make a picture of this in his mind if only it has been properly put before him. All matter in the world is made up of minute parts or particles. In a solid, these particles are locked together so tightly that you must tear them forcibly apart if you wish to alter the shape of the solid piece. If I bend or break this wood, I have to force the particles to move round each other, and I have great difficulty in doing it. But in a liquid, though the particles are still held together, they do not cling so tightly, but are able to roll or glide round each other, so that when you pour water out of a cup onto a table, it loses its cup-like shape and spreads itself out flat. Lastly, in a gas, the particles are no longer held together at all, but they try to fly away from each other, and unless you shut a gas in tightly and safely, it will soon have spread all over the room. A solid, therefore, will retain the same bulk and shape unless you forcibly alter it. A liquid will retain the same bulk, but not the same shape, if it be left free. A gas will not retain either the same bulk or the same shape, but will spread over as large a space as it can find wherever it can penetrate. Such simple things as these you must learn from books and by experiment. Then you must understand what is meant by chemical attraction, and though I can explain this roughly here, you will have to make many interesting experiments before you will really know this wonderful fairy power. If I dissolve sugar in water, though it disappears, it still remains sugar, and does not join itself to the water. I have only to let the cup stand till the water dries. The sugar will remain at the bottom. There has been no chemical attraction here. But now I will put something else in water which will call up the fairy power. Here is a little piece of the metal potassium, one of the simple substances of the earth. That is to say, we cannot split it up into other substances. Wherever we find it, it is always the same. Now, if I put this piece of potassium in the water, it does not disappear quietly like the sugar. See how it rolls round and round, fizzing violently with a blue flame burning round it, and at last goes off with a pop. What has been happening here? You must first know that water is made of two substances, hydrogen and oxygen, and these are not merely held together, but are joined so completely that they have lost themselves and have become water. And each atom of water is made up of 2 atoms of hydrogen and 1 of oxygen. Now, the metal potassium is devotedly fond of oxygen, and the moment I threw it on the water it called the fairy chemical attraction to help it, and dragged the atoms of oxygen out of the water and joined them to itself. In doing this, it also caught part of the hydrogen, but only half, so the rest was left out in the cold. No, not in the cold, for the potassium and oxygen made such a great heat in clashing together that the rest of the hydrogen became very hot indeed, and sprang into the air to find some other companion to make up for what it had lost. Here it found some free oxygen floating about, and it seized upon it so violently that they made a burning flame, while the potassium, with its newly found oxygen and hydrogen, sank down quietly into the water as potash. And so you see, we have got quite a new substance, potash, in the basin, made with a great deal of fuss by chemical attraction drawing different atoms together. When you can really picture this power to yourself, it will help you very much to understand what you read and observe about nature. Next, as plants grow around you on every side, and are of so much importance in the world, you must also learn something of the names of different parts of a flower, so that you may understand those books which explain how a plant grows and lives and forms its seeds. You must also know the common names of the parts of an animal and of your own body, so that you may be interested in understanding the use of the different organs, how you breathe, how your blood flows, how one animal walks, another flies, and another swims. Then you must learn something of the various parts of the world, so that you may know what is meant by a river, a plain, a valley, or a delta. All these things are not difficult. You can learn them pleasantly from simple books on physics, chemistry, botany, physiology, and physical geography. And when you understand a few plain scientific terms, then all by yourself, if you will open your eyes and ears, you may wander happily in the fairyland of science. Then, wherever you go, you will find tongues in trees, books in the running brooks, sermons in stones, and good in everything. And now we come to the last part of our subject. When you have reached and entered the gates of science, how are you to use and enjoy this new and beautiful land? This is a very important question, for you may make a twofold use of it. If you are only ambitious to shine in the world, you may use it chiefly to get prizes, to be at the top of your class, or to pass in examinations. But if you also enjoy discovering its secrets, and desire to learn more and more of nature and to revel in dreams of its beauty, then you will study science for its own sake as well. Now, it is a good thing to win prizes and to be at the top of your class, for it shows that you are industrious. It is a good thing to pass well in examinations, for it shows that you are accurate. But if you study science for this reason only, do not complain if you find it dull and dry and hard to master. You may learn a great deal that is useful, and nature will answer you truthfully if you ask your questions accurately. But she will give you dry facts, just such as you ask for. If you do not love her for herself, she will never take you to her heart. This is the reason why so many complain that science is dry and uninteresting. They forget that though it is necessary to learn accurately, for so only we can arrive at truth, it is equally necessary to love knowledge and to make it lovely to those who learn. And to do this, we must get to the spirit which lies under the facts. What child which loves its mother's face is content to know only that she has brown eyes, a straight nose, a small mouth, and hair arranged in such and such a manner. No, it knows that its mother has the sweetest smile of any woman living, that her eyes are loving, her kisses sweet, and that when she looks grave, then something is wrong which must be put right. And it is in this way that those who wish to enjoy the fairyland of science must love nature. It is well to know that when a piece of potassium is thrown on water, the change which takes place is expressed by the formula K plus H2O equals KHO plus H. But it is better still to have a mental picture of the tiny atoms clasping each other and mingling so as to make a new substance, and to feel how wonderful are the many changing forms of nature. It is useful to be able to classify a flower, and to know that the buttercup belongs to the family Ranunculaceae, with petals free and definite, stamens hypogynous and indefinite, pistil apocarpus. But it is far sweeter to learn about the life of the little plant, to understand why its peculiar flower is useful to it, and how it feeds itself and makes its seed. No one can love dry facts. We must clothe them with real meaning and love the truths they tell if we wish to enjoy science. Let us take an example to show this. I have here a branch of white coral, a beautiful, delicate piece of nature's work. We will begin by copying a description of it from one of those class books which suppose children to learn words like parrots and to repeat them with just as little understanding. Coral is formed by an animal belonging to the kingdom of radiates, subkingdom polyps. The soft body of the animal is attached to a support, the mouth opening upwards in a row of tentacles. The coral is secreted in the body of the polyp out of the carbonate of lime in the sea. Thus the coral animalcule rears its polypidum or rocky structure in warm latitudes, and constructs reefs or barriers round islands. It is limited in range of depth from 25 to 30 fathoms. Chemically considered, coral is carbonate of lime. Physiologically, it is the skeleton of an animal. Geographically, it is characteristic of warm latitudes, especially of the Pacific Ocean. This description is correct, and even fairly complete, if you know enough of the subject to understand it. But tell me, does it lead you to love my piece of coral? Have you any picture in your mind of the coral animal, its home, or its manner of working? But now, instead of trying to master this dry, hard passage, take Mr. Huxley's penny lecture on coral and coral reefs, and with the piece of coral in your hand, try really to learn its history. You will then be able to picture to yourself the coral animal as a kind of sea anemone, something like those which you have often seen, like red, blue, or green flowers, putting out their feelers in sea water on our coasts, and drawing in the tiny sea animals to digest them in that bag of fluid which serves the sea anemone as a stomach. You will learn how this curious jelly animal can split itself in two, and so form two polyps, or send a bud out of its side, and so grow up into a kind of tree bush of polyps, or how it can hatch little eggs inside it, and throw out young ones from its mouth, provided with little hairs, by means of which they swim to new resting places. You will learn the difference between the animal which builds up the red coral as its skeleton, and the group of animals which build up the white, and you will look with new interest on our piece of white coral, as you read that each of these little cups on its stem with delicate divisions like the spokes of a wheel has been the home of a separate polyp, and that from the sea water each little jelly animal has drunk in carbonate of lime, as you drink in sugar dissolved in water, and then has used it grain by grain to build that delicate cup and add to the coral tree. We cannot stop to examine all about coral now. We are only learning how to learn, but surely our specimen is already beginning to grow interesting, and when you have followed it out into the great Pacific Ocean, where the wild waves dash restlessly against the coral trees, and have seen these tiny drops of jelly conquering the sea and building huge walls of stone against the rough breakers, you will hardly rest till you know all their history. Look at that curious circular island in the picture, covered with palm trees. It has a smooth, large lake in the middle, and the bottom of this lake is covered with blue, red, and green jelly animals, spreading out their feelers in the water and looking like beautiful flowers. And all round the outside of the island similar animals are to be seen washed by the sea waves. Such islands as this have been built entirely by the coral animals, and the history of the way in which the reefs have sunk gradually down as the tiny creatures added to them inch by inch is as fascinating as the story of the building of any fairy palace in the days of old. Read all this, and then, if you have no coral of your own to examine, go to the British Museum and see the beautiful specimens in the glass cases there, and think that they have been built up under the rolling surf by the tiny jelly animals, and then coral will become a real living thing to you, and you will love the thoughts it awakens. But people often ask, what is the use of learning all this? If you do not feel by this time how delightful it is to fill your mind with beautiful pictures of nature, perhaps it would be useless to say more. But in this age of ours, when restlessness and love of excitement pervade so many lives, is it nothing to be taken out of ourselves and made so to look at the wonders of nature going on around us? Do you never feel tired and out of sorts and want to creep away from your companions because they are merry and you are not? Then it is the time to read about the stars and how quietly they keep their course from age to age, or to visit some little flower and ask what story it has to tell, or to watch the clouds and try to imagine how the winds drive them across the sky. No person is so independent as he who can find interest in a bare rock, a drop of water, the foam of the sea, the spider on the wall, the flower underfoot, or the stars overhead. And these interests are open to everyone who enters the fairyland of science. Moreover, we learn from this study to see that there is a law and purpose in everything in the universe, and it makes us patient when we recognize the quiet, noiseless working of nature all around us. Study light and learn how all color, beauty, and life depend on the sun's rays. Note the winds and currents of the air, regular even in their apparent irregularity, as they carry heat and moisture all over the world. Watch the water flowing in deep, quiet streams, or forming the vast ocean, and then reflect that every drop is guided by invisible forces working according to fixed laws. See plants springing up under the sunlight. Learn the secrets of plant life and how their scents and colors attract the insects. Read how insects cannot live without plants, nor plants without the flitting butterfly or the busy bee. Realize that all this is worked by fixed laws, and that out of it, even if sometimes in suffering and pain, springs the wonderful universe around us. And then say, can you fear for your own little life, even though it may have its troubles? Can you help feeling a part of this guided and governed nature, or doubt that the power which fixed the laws of the stars and of the tiniest drops of water, that made the plant draw power from the sun, the tiny coral animal its food from the dashing waves, that adapted the flower to the insect and the insect to the flower, is also molding your life as part of the great machinery of the universe, so that you have only to work and to wait and to love. We are all groping dimly for the unseen power, but no one who loves nature and studies it can ever feel alone or unloved in the world. Facts, as mere facts, are dry and barren, but nature is full of life and love, and her calm, unswerving rule is tending to some great, though hidden, purpose. You may call this unseen power what you will, may lean on it in loving, trusting faith, or bend in reverent and silent awe. But even the little child who lives with nature and gazes on her with open eye must rise in some sense or other through nature to nature's God. End of Lecture 1. This recording is in the public domain.